Hi everyone, this is Morgan with Positive Approach to Math. We are moving right along in our algebraic expression topic, moving on to lesson 2, combining like terms. This is one of the most important lessons. It's something you will use in all levels of math, and I just want to make sure we are good to go with it. So, as always, we will have for your information. Then we will segue into a couple examples. We will have a summary and some helpful hints. And then we'll wrap up with some you tries, and they're designed for you to try on your own. At the end of this video, I will lead you to a link where you can check your work for the you tries. An answer key will post and you can check your work. Or you can click on another link that will lead you to a detailed breakdown of those you tries, going through each of them if you need some extra help or guidance. Keep pushing along, you're doing a great job, and let's get started with combining like terms. So let's get started with for your information. So first we need to talk about like terms, which we discussed in lesson 1. So you see in math, everything builds. Like terms are things that have the same variable or variables and the same exponent on each variable. And remember, if they don't have a variable, they are constants, and all constants are like terms. So once you identify two like terms, you can combine them or simplify them by adding or subtracting their coefficients. So I always use the example of Oreos, right? If I buy a package of Oreos, right, they are all singled stuffed Oreos. If I want doubled stuffed Oreos, I buy a package of doubled stuffed Oreos. I never can find a package where they're single and doubled stuffed, right? So if I have 3 regular Oreos and you have 2 regular Oreos and we put them all together, we would have 5 regular sized Oreos. It does not change the stuffing, this inside cream to 5 times the amount or anything like that. It's just we have 5 single Oreos. Now, if I have 6 doubled stuffed Oreos and you have 2 doubled stuffed Oreos, we could put those in a group and say we have 8 double stuffed Oreos, right? Or say I had 6 double stuffed Oreos and I ate 2 double stuffed Oreos. I went from 6 and then I took 2 away, I went down to 4. But they are all still singled double stuffed Oreos, right? It didn't change the inside. So it's not going to change our exponent when we add or subtract like terms. It's simply going to change the quantity of those like terms. Instead of having 2x squared and 1x squared, you can push them together to have 3x squared. Okay, so we sometimes will see this as simplifying, but we call it combining like terms. And remember, all constants are like terms. So if something doesn't have a like term, we just bring it down in the expression. So looking at the first example, so we're moving on to our examples, I see a 13x squared and a 2x squared. They're like terms. They both have the variable x and it's to the second power. So we can combine their coefficients. Remember, coefficients are the number in front of any variable. So 13 plus 2 will give us 15x squared. And so we just consolidated that a little bit, okay? Looking at the next example, we have 20y to the fourth minus 8y to the fourth. So those are like terms. They both have that variable of y and they're raised to the fourth power. So we can subtract them. 20y to the fourth minus 8y to the fourth will give us 12y to the fourth. The variable y did not change, and that exponent on that variable, 4, did not change as either. The only thing that changed was that 20 minus 8. We simplified it to 12, okay? And this last example in this first row, we have a mix of things. So we see that algebraic expression, and I'm going to skim it and say, okay, do you see any like terms? So I see 3 things with a z. However, only 2 of them are like terms, and it would be that 2z squared and the 6z squared. Those would be like terms because of that second power on each of those z's. So I can combine those first. 2z squared plus 6z squared. I would add them. That will give me 8z. I'm going to put a line there so we can make sure it's not a 2 squared. So I can combine those like terms. Now I skim and I say, okay, do I see any other like terms? I see this z to the first power, but it doesn't have any other friends. So in that case, I just bring it down. And then last but not least, I see a constant 5. Doesn't have any friends, so I just bring it down. We can't let those guys be lonely. A lot of times you're going to see me put things in order with the highest exponent first, just like I have here, 8z squared, and then I go in descending order. That is called standard form of an algebraic expression or a polynomial, which we'll get to later in our Math Algebra 1 journey. And then we have 2 more examples. We'll wrap up with the summary and helpful hints that you see here, and then finally those you tries. So I really gave you something good to work with in this next example. I gave you things with x and y, and they had different exponents. So you really have to match. We can't say, oh, they all have an x and y. Let's just combine them in one thing, because they all don't have the same exponent on the x and the same exponent on the y. So looking at this first term, it's an x squared and a y to the first. So I'm going to squiggle that, okay? Do I see any other term here that has an x squared and a y to the first? No. Yes, x squared, y to the first, and no. So I can combine that 12x squared y to the first and that 4x squared y to the first. Now I'm adding, and I know I'm going to be adding because it's a positive 12 plus 4. So we're changing that coefficient. 12 plus 4 is 16 x squared y to the first. Those exponents will not change. They just get brought down, right? When I have 2 double stuffed Oreos and 1 double stuffed Oreo, I end up having 3 double stuffed Oreos. It does not change that filling. Okay, now looking at this next term, whoopsie, negative 3x y to the second. So now the x is to the first degree and the y is to the second degree. And so I'm going to skim and see if anything else has that, and that negative 7 does as well. And so now what we're going to be doing is negative 3 minus 7. So we have negative 3, and then we're going to subtract 7 more. That's going to leave us with negative 10. And then we bring down x, y to the second. And so we consolidated those 4 terms into 2 by combining the like terms. And last but not least, we have one more with w. So looking at this guy, we see we have some things with w, some things that aren't. Those are our constants. I see w to the second power, I see a w to the first power, and then I see something without a w. So I'm going to just go down the line. I'm going to say, okay, here's w to the second. Skim, do I see anything else with a w to the second? I do. Remember, this is like a coefficient of negative 1. So that's negative 1w squared plus 3w squared, which will give you 2w squared. Okay, moving down the line, I see just a plain old 7w to the first power. And this is why I like to underline things, because now I know, okay, go to everything not underlined and check that. If it's underlined, it's already used. We can't use it again. I don't see any other just singular w's, so I like to draw an arrow, and I bring that down. And then last but not least, I see a constant, negative 5, and I skim over to the last thing not underlined. Another constant, 10, so I'm going to be doing negative 5 plus 10, which will give me positive 5. This is in standard form, and we simplified and combined all like terms, okay? So some helpful hints we have here. When we're combining like terms, it is important to remember that we are using addition or subtraction only. So when someone says combine like terms, think adding and subtracting, and you're changing the coefficient, the number in front of the variable. That is the only thing changing, and it will change by either adding 2 things or subtracting. You will never, ever, ever multiply or divide, okay? The exponents of the variable will not change. So think of that doubled stuffed Oreo. If I have 1 and you have 2, it doesn't change the stuffing of the Oreo. It just gives us 3 Oreos that are doubled stuffed, okay? Same thing here. If I have 1x² and you have 2x², it does not change that exponent. It still gives us x², but now instead of having 1 and 2, we push them together to have 3, okay? Or we put them all together. Make sure when you're looking for like terms that the variables match and the exponents on each variable match, right? That's what it means to be like terms, okay? Sometimes you might hear something say, or the directions say simplify an expression or simplify, or using simplifying, I guess. I'm not really sure exactly what. But you might see something referenced as simplifying. And when you see that, what they mean is, can you consolidate your algebraic expression? Can you combine any like terms? Can you push anything together? So you might see that word simplifying in place of combining like terms, but just know, okay, when they tell me simplify, they want me to make it the simplest algebraic expression possible. Okay, and we're going to talk more about different ways to simplify, or different skills that are going to be added onto that. Okay, and now we'll leave you with 6 U tries. They are really fun, great problems. That was an awesome lesson. You did a great job. Like I said, just a reminder, you can click the link for you to check your work on these 6 problems. If you need a little extra help, you can click the link below that one to see the detailed worked out breakdown of these 6 problems. But keep chugging along, keep up the great work, and I hope to see you again soon.